Hello dear students, today I will talk about line integral of vectors. So line integral of a vector can be in 1D, 2D or 3D. So for 1D there is only one parameter x. For 2D, as you know, there are two parameters x and y, and for 3D there are three parameters x, y and z. So how the line integral in vector calculus is written? There are three types of line integral. The first one is we can integrate any scalar function phi along a line. So this line can be in 1D, 2D or 3D. Number 2, integrating the dot products of two vectors, where the first vector is the function and the second vector is the line or the path. So line integral is also called path integral. Since we are integrating along a path. So this type of integration, if we want to show physically, so this is our x-axis in 1D and we simply just take a path from point A to point B and we have a function phi. So this function can be anything. This function can be 2x, 2x square, anything. So if you integrate these functions from A to B, then we get the line integral of the function. And now in 1D, simply this dr will be x of I. And when we are integrating the scalar function, I will be outside the integration because I is not integrable. It is constant with change of x. In 2D, if we integrate any function from A to B, then our dr simply will be, this will be dxi plus dyj. And in 3D, dr will be dxi plus dyj plus dzk. Here dr will be dxi plus dyj plus dzk if we simply use the Cartesian coordinate. If you use different coordinate system, the definition of dr will be changed. Now, we are discussing about the second type of line integration, which is the integration of a vector. So the final integration is simply the dot product of two vectors. And the number 3 type is the integration of the cross product of two vectors, where along the two vectors, one is our line integral component, that is dl, and r the integrating function. This is a simple example. So these type of examples, we can see the scalar field. When we integrate the line integration of scalar field, the example is simply phi is the density and r is the line, dr is line integral. We can get the mass of any body. From f dot dr is the function phi, the integration function phi is the force. Then f dot dr is simply the work done. And in case of cross product, this type of integration comes in Biot-Savart's law. just say the Biot-Savart's law, there will be some constant dl cross r. Biot-Savart's law. So you see that the three types of line integration can be occurred in vector calculation. First one is any scalar field can be integrated with respect to some vector path. Second one is any vector function can be integrated with the dot product of the line path. And the third one, any vector function, the cross product with the path. Now, if we know the initial and final point, if it is known to us the values of initial and final points, the coordinates, then it is called the closed integration. And if we don't know the initial and final point of the integration, then it is called the open integration. So the path integral is of two types. One is closed and another is open. So closed is what? When we know the initial and final points, we know the coordinates of the initial and final points. Now, today's lecture is done. In my next lecture, I will discuss with examples these three types of line integration in vector calculation. Thank you for watching.